Okay, hi everybody. We're going to look at how to set up systems of equations given word problems, and just different applications here. So once we get it set up, you're going to use some of the skills that you learned in 10.1 through 10.4 to solve the system. So here's the first example. You can pause the video and write it down. You're going to have some problems like this in your homework. The sum of three numbers equals 8. 2 times the smaller number is 2 less than the largest. The sum of the largest and smallest is 5. Find the three numbers. All right, so when you read through these problems, read it through once, and then go through and figure out what it is that you're trying to answer. So it might take 2-3 times to read these problems so that you really understand what the problem is asking you to do. And then let's go back and look at all the important vocabulary words, because we're going to need to translate these English statements into math statements. So the sum of three numbers equals 8. 2 times the smaller number is 2 less than the largest. The sum of the largest and smallest is 5. Find the three numbers. So our goal, what we're trying to find, is three numbers. And it's talking about a smaller number and a larger number. So we have three different numbers. What we want to do is we want to create variables for these three numbers. So since there's three numbers, I'm going to use the variables x, y, and z to represent the three numbers. So I can say we're going to let x equal the smallest number. It doesn't have to be this. You could say it equals the biggest number if you wanted to. But we have to let one variable equal the smallest number. I'm going to let y equal, it doesn't talk about the middle number, but the middle number must exist if there's a smallest and a largest. So I'm going to let y equal the middle number, and then I'll let z equal the largest number. So we have our three variables. Now we need to set up a system of equations based on what we're seeing here. The sum of the three numbers equals 8. So the sum means we're going to add the three numbers together and we get 8. So I know one of my equations is going to be x plus y plus z is equal to 8. All three of them added together is 8. So they must be relatively small numbers because we're adding three of them together and it totals 8. This next part, so that's one equation right there. This next part is going to give us a second equation. So let me do that in a different color. 2 times means multiplication. 2 times the smaller number, and remember our smaller number was x, is, when you see the word is, it's going to be a clue that there's an equal sign, most likely, is 2 less than the largest. So I want you to think about what that equation would look like. 2 times the smaller number, so how would you write 2 times the smaller number? Well, our smallest number is x, so 2 times that is 2x. Is means we're going to set that equal to 2 less than the largest. So whatever the largest number is, which is z, 2 less than that is z minus 2. So think of, if you have trouble with like how to put it into a math statement, into an equation, think of an actual number. Like let's say that z was 10. It can't be 10 because it's too big, so three numbers add to 8. But let's just pretend for a second that z was 10. Well, what's 2 less than 10? It's 8. So you would be, what are you doing? You're subtracting 2 from that number. So instead of 10, I just have some variable, I don't know what it is, z, but 2 less than z is z minus 2. All right, so we have our second equation. The third equation is going to come from this third statement. The sum, again, sum means we're going to add the sum of the largest, which is z, and the smallest, which is x. So the sum of those two is, remember that's equals 5. So my third equation is, I have x plus z is equal to 5. And then you can solve that system of equations I'll do this one, but I'm not going to solve all of the systems. Hopefully you have that down from the previous videos and classes. So let's do this one though. We have, there's different ways that you could do this. One way is we could solve this equation right here for z. If I do that, if I solve this for z, equation 2, solve for z, I'm just going to add 2 to both sides. So I'd have 2x plus 2 is equal to z. It's just rearranging that equation. And then if I know that z is equal to this, I can substitute that in to equation 3. And so I'd have x plus, instead of writing z, I'm going to write 2x plus 2 because that's equal to z. And I don't need to put it in parentheses. And that's equal to 5. And don't need to put it in parentheses because I'm not multiplying it by anything. So then I can combine these like terms. I get 3x plus the 2 equals 5. And then subtract 2 from both sides. And I get 3x equals 3. Divided by 3, and you get your x. Our x is equal to 3 divided by 3, which is 1. Put a box around that. And then if we know x is 1, if x is 1 here, then I can find z, because 1 plus z is equal to 5. So subtract the 1 from both sides, and I get z is equal to 4. So far that makes sense. Z is our larger number, x is our smallest number. If we, so it should turn out that way, which it does. And now I know x and I know z, so if I plug that into equation 1, x is 1 plus, I don't know y yet, plus z equals 4. I'm putting that in, 1 in for this and 4 in for this equals 8. So this is 5 plus y is equal to 8. Subtract 5, and you get y equals 3. 8 minus 5 is 3. All right. Second example here. 725 tickets were sold for a game for a total of $1,100. If adult tickets sold for $2 and children's tickets sold for $1, how many of each type of tickets were sold? What is this asking us? Well, we're trying to figure out, the question oftentimes comes at the end, how many of each type of tickets were sold? So we have 2 types of tickets. We have adult tickets and we have children's tickets. So I'm going to use variables to represent that because I don't know what those things are. So I'm going to let x equal the number of, you could do adult or children, but I'm going to do adult tickets. And my y is going to be number of children's tickets. Now you could put A for adult tickets and C for children's tickets. Doesn't matter. I'm just using X and Y just because. So I know that there were 725 tickets that were sold. So the total number of tickets, adult tickets and children's tickets, has to equal that number. So X plus Y, the number of adult tickets plus the number of children's tickets, is 725. And then we also know that the adult tickets, we're bringing in $2 for each one of those. So the amount of money that we're going to make off of these tickets is, the adults, we're going to get $2, so 2 times however many tickets we sell, plus we get $1 for every child's ticket. So just 1 times Y is just Y. And that is telling us how much money we're bringing in, and we know that that's equal to $1,100. All right, so for this problem, I would use elimination. You could just multiply this top equation by a -1 and then add down, and the y's will drop out, and then you can plug it back in to solve for x. All right, next problem. I want you to pause the video so that you can read this to yourself and try to set up the equation, and then come back and I'll help you with it, or see how you do on it. Okay, so the question that's being asked is how much did he invest at each rate? So I let X be the amount he invested at 4% and Y is the amount that he invested at 8%. So I want to figure those things out. That's what the question is asking. So that's what you want your variables to represent. And then we know that his total investment was this $13,000. I'm sorry. So the amount he invested at 4% and the amount he invested at 8% has to total that $13,000. And then he's getting interest, the amount that he invests at 4%, he's getting 4% interest, and 4% as a decimal, when you're working these out, if it's a percentage, you need to turn it into a decimal. And 8% as a decimal is 0.08. You move the decimal over 2 places. So he's making 4% or 0.04 of whatever he invests at 4%, plus he's making 8% times the amount that he invests at that percent. And we know that the total after 1 year is $760. So for this problem, we have decimals. You can solve the equation with decimals, but what I would do is I would multiply equation 2 by 100 to move the decimal over 2 places, and then you don't have to deal with those decimals. So if you multiply 0.04 that's an arrow, 0.04 times 100, it becomes 4x plus, and that's going to be 8y, and then it's going to be 760 times 100, adds 2 more zeros here, so 76,000. And so then my equation 1, I'm writing right underneath here. I would do elimination with this. You could do substitution as well, but if you multiply equation 1 here by a -4 all the way across, and then add your terms, add your columns down, you should eliminate x easily and then be able to solve for y. If you're having trouble with these, bring your questions to me. Okay, we're going to do 2 more problems on a disinfectant, adding different percentages, and then I'm going to do one on the speed of the current. So you can read this real quick. It takes 3 hours to travel 33 miles downstream and 4 hours to travel back upstream, and that's 28 miles. What is the speed of the boat in still water? What is the speed of the current? I'm going to do these in the next video.